This is asking us to graph a system of equations. But it's not actually regular equations, it's a system of inequalities. This one is greater than or equal to, this one is less than. You graph these almost the same way as regular lines, just with one little difference. So if we're going to graph this first one, let's see. We've got 1/2 x minus 4, so we go down to -4. And we go up at a rate of 1/2. So up 1, right 2, up 1, right 2, up 1, right 2, and maybe I'll go backwards, down 1, left 2. All right. Now, in order to connect these dots, first we have to know, is y allowed to be equal to these things? And in this case it is, because it's or equal to. That means we can draw a nice solid line. Then the other thing we care about is it greater than or less than? And in this case, y should be greater than this. So if we have a big y, a y that's greater than this line, a big Y means it's above. Big Y's go up. So we are looking at everything that is above that line. So we're going to do some shading here. I'm going to do my best using the tools that I have. This is me shading in that whole area above this line. Then we're going to do the same thing with the second one, 3x minus 1. So we start down at -1. 3x, if you want rise over run, is the same as 3 over 1x. So we go up 1, 2, 3, right by 1. 1, 2, 3, right by 1. And we can go backwards too. Down 3, left 1. And maybe that's enough. Then we want to connect these dots, but again we got to consider, is y allowed to be equal to this? And in this case it's not, because this is less than. If it was less than or equal to, that would be different. But because it's a less than, y is not actually allowed to equal this line, and we show that by making it a dotted line to show, hey, these points are not included. All right, we've got our dotted line. And then y needs to be less than these things. Well, less than means it's a small y, which is in the down direction. So we're going to shade in everywhere under this line. So this line is sloping upward. You can see the area under it would be like over here. So again, I'm going to do my best shading using the tools I have. All right, this is the area under that line. Now, the solutions to a system. If you want to know the solutions, they're the points that are true for both of these, which is the area where both of the shadings overlap. And so I'm going to show that by saying, okay, well, there's dotted line here, solid line here. Everywhere in here has double shading going on. And so any point, like over here, if we go to the point like, I don't know, 6, 2, this point is a solution to the system. Whereas something over here like, I don't know, -3, 5, a point like this is not a solution, because even though it's a solution for the pink one, it's in the pink shaded region, it's not a solution to the other. So only points in this blue shaded area, the overlap, is a solution to the system.